In lesson 7.2, we're going to learn how to solve system of equations using substitution, which is an algebraic method where you solve the system by hand instead of looking at the graphs. We're going to use the equations to do that. So in this first problem, example 1, we will say, I'm going to tell you that the first equation is y equals 5. And the second equation is negative 8x plus 9y equals 13. Those are two different equations. They represent two different lines on a coordinate plane. They cross somewhere in that plane, and we need to figure out where that is, but we're going to use the equations to do it. Y equals 5 all by itself. So we can take this value and we can substitute it into the place that it's equivalent to. Here's a y and here's a y, and those are the same. So in our next line of work, I'm going to copy the whole first part, but then notice where I put the y. I'm not going to put the literal y. I'm going to put what the y is equal to. I'm going to put the 5 right there. Still equals 13. All of these parts are the same, but I combined these two equations by plugging in what I know about that y value. Then if you simplify that, negative 8x plus 9 times 5 turns into 45 equals 13. And then you can solve it just like normal, like 7th grade. Subtract 45, subtract 45. Negative 8x equals 13 minus 45 is negative 32. So now we're going to divide by negative 8, divide by negative 8, and x equals 4. We're not done though, because remember when you solve a system, you're looking for where those two lines intersect on the graph, which means we need a point with an x and a y value. So over here on the side, I'm going to put the answer together. The x value is 4, and the y value is 5. Those two numbers together make up our answer. Let's try another one like that. In this problem, I'm going to tell you, let's call this example 2. The first equation is negative x minus 3y equals negative 9. And the second equation is y equals 2. Here's a y, and here's a y. So I can plug in the number that I know. Negative x minus 3, I'm just copying that longer equation, but instead of the y, I've got to put the 2. And then copy the equals negative 9. And then I can go ahead and simplify that and solve it. Negative x is going to drop down. Negative 3 times 2 is going to make that minus 6 equals negative 9. And then plus 6, so negative x equals negative 3. This x isn't by itself yet though, there's still a 1 there, remember. So we have to divide by negative 1, divide by negative 1, and x equals positive 3. In order to write our answer, we need to put the x and the y values together. So I'm going to do that for this problem now. X was 3 and y was 2. So that makes our answer all together. If they give you another problem, this one's going to be pretty similar. I just don't want you to get tripped up. In this example, they give you the x value instead of the y value, but we can still do the problem the same way. Negative x minus y equals negative 6. And then they tell you that x equals 1. So now instead of plugging that number into the y spot, we plug it into the x spot because that's the number that we know. So I'm going to copy the negative, but instead of the x, I'm going to write what it's equal to. I'm going to write the 1. Oh, I'm sorry, I forgot I was doing those in orange. Oopsie. The 1 goes in that x spot. And then copy the rest. Minus y equals negative 6. And now you can solve for that y value. We're going to have to do the adding first, so add 1 on both sides. Negative y equals negative 5. Remember, there's a 1 here, so divide by negative 1, divide by negative 1, and y equals 5. You have to put these two numbers together for your answer. The x value is 1 and the y value is 5. Okay, this one's going to be a little trickier. Are you ready? In this problem, we're going to call it example 4. They're going to give you two equations that are both equal to y, but neither one of them is just a number. Before we had y equals 5 or x equals 2. Here we have y equals 2 different equations. We do still have two letters, two variables that are by themselves that can be substituted. So hang on tight here. Is your brain ready? This part is equal to this part. This part is equal to that same variable. They are both equal to y. So that means in my next step, I can write them both equal to each other. I can take the 3x plus 2 and say that that equals x minus 6. They're both equal to y, so that means that they must be equal to each other. At this point, you have to get your variables on the same side. They're on opposite sides of that wall, so you cannot combine them. You have to do the opposite. Minus x and minus x. So 2x plus 2 equals negative 6, because those are gone. And then minus 2, 2x equals negative 8. And then we divide by 2, and x equals negative 4. In this problem, we're not done yet, though, because we know the x value. We know that in our final answer, the x coordinate is negative 4, but we don't know the y coordinate because they didn't give us y equals just a number here. So you can pick whichever one of these two equations you want. It doesn't matter. Just pick one. And we're going to take that negative 4 and plug it in. Y equals 3x plus 2, so 3 times negative 4 plus 2. 3 times negative 4 is negative 12, plus 2 gives us negative 10. So that is the y value for this problem. You have to do a little bit of an extra step since it's a little more complicated. Let's do one more example that looks like that. Y equals 3x plus 3 and y equals 5x plus 9. Both of those equations are equal to y, which means we can set them equal to each other. So 3x plus 3 equals 5x plus 9. There's variables on both sides, so we need to do the opposite to get them together. That's going to give us negative 2x plus 3 equals 9, minus 3, minus 3. And then we're going to divide by the negative 2. So x equals negative 3. Are we done yet though? Nope. We know that the x coordinate is negative 3, but we don't know the y coordinate. We need to take that negative 3 and plug it back into the equation. It doesn't matter which one, I'm just going to choose the first one. Y equals 3 times negative 3 instead of the x value. Three times negative 3 is negative 9. Negative 9 plus 3 is negative 6. So that is the answer for this problem. Honestly, guys, I am not really expecting you to be able to do this whole lesson, this whole IXL without talking to me. It's really complicated, and those problems all have a lot of steps. So please, 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 when you're struggling on the IXL, because you're probably going to, please reach out to me so that I can help you finish it up.